Hi class, for this specific problem, we're going to be working on a 99% confidence interval for mu, and then we only have the value of the standard deviation of the actual sample. So basically this is going to be a CI for mu, and the values of sigma is not given. So therefore, this is going to be a T interval. Okay, so this is the basic idea. Let's first actually find the critical value. So let's do this one the long way so that you guys have another example on how to approach these problems if they were to ask for the standard error critical value and then every one of the calculations. So for the critical value, we have that the values of C is equal to 0.99. Therefore, alpha is equal to 0.01. And then alpha divided by 2 is equal to 0.005. And then the basic sketch is going to be as follows. So we're looking at a bell-shaped distribution, and this portion here is equal to 0.99. The area on each of the tails, it's 0.005. So this portion would be 0.005, and this portion is going to be 0.005. The next portion, since we're dealing with a T interval, is to find the degrees of freedom. Now, the degrees of freedom for this one, it's going to be n-1. So in this case, sample of, well, technically 7. So 7 minus 1 is equal to 6. So we're looking at technically 6 degrees of freedom. Now, let me show you how to run this in the calculator. And not all actual calculators have the code. So for this particular one, in order to find the proper critical value, you're going to hit stats. Actually, wait. You're going to hit second distribution. Then number 4, inverse T. The area in one tail is 0.005, degrees of freedom equal to 6. Then please run it. And your calculation is going to be negative 3.707. So the main T value that we need, it's the one on the right. So I'm going to round to 2 decimal places. We're going to be using 3.71, rounding to a total of 2 decimal places. That is going to be our actual critical value. So let me just circle it here. Critical value, it's approximately T, which is approximately 3.71. This is the value that we would be using for any of the calculations. Now, remember the actual standard error in the calculation. So technically, this is the formula that we're going to be using. The standard error is composed of the critical value, standard deviation, over the square root of n. So for this one, we're going to find that the values of E, it's going to be equal to a T of alpha times the standard deviation of the sample over the square root of n. So for this one, the critical value ended up being 3.71 times the standard deviation. That would be 0.04 over the square root of n. N is 7. So take a second and evaluate the standard error. We'll round that to 4 decimal places. So please evaluate. I'm getting 0.05, 61, rounding to 4 decimal places. Now, the final portion, it's actually going to be the calculation of the confidence interval. So the CI, it's going to be composed of the following. So mu, it's going to be bounded between the following 2 values, x bar plus the E, and then x bar minus the E. And let me just calculate x bar plus or minus the actual value of E, which in this case, it's going to give us the mean of the sample was 0.12 plus or minus the 0.0561. So take a second and calculate that. And the actual interval that I'm getting is 0.0639 and then 0.1761. So your final answer is going to say something along the following lines. Now, remember that you're creating a confidence interval. So this is just an interval where we may have the value of the mean, but there's a little bit of error. So you have to mention the level of the interval. In this case, we're conducting a 99. So you would simply say that the 99% CI for mu is, and then just rewrite it as 0.0639 to 0.1761, and then don't forget the units. The units that they're using are nitrogen oxide and this is emissions, and then they're also adding that it's grams per mile. So that would be your final answer. All confidence intervals have to have the actual level of the that we're running it, since technically that is the indication that we're carrying about a 1% error. Now, let me show you how to run these using the calculator. If you notice the original problem, they're not asking for the standard error or the critical value. So some of these problems on the homework, all they want you to run is the proper interval. In this case, it's going to be a t interval. So the commands would be stats. You go all the way to test. Within test, it'll be number 8. And then you're looking at the mean being, let me go back to review that. The mean being 0.12, the standard deviation 0.4, 7 values of n, and then 99. So please take a second and run it. Now we're going to get a little bit of error, and this is because of the actual critical value. We did a little bit of running there too. Let's compare it to the code. Most of the problems on the homework, they want the code. So we're looking at 0.0639 and 0.1761. Pretty good. So we're matching rounding to 4 decimal places. The software may differ there, but overall, check that the homework questions are, well, if they're saying technology, then they want you to run, in this case, the code.